In this example, we are going to take a function and graph it using its translations, or at least identify um, the that are happening from the parent function to what the given function is. So the first thing you're going to do is identify what the parent function would be. So for 3x to the fourth minus 18, the parent function would be y equals x to the fourth. All right. And then in relation to that parent function, how does the leading coefficient and how does the minus subtracting 18 affect it? So the leading coefficient of 3 stretches the graph vertically. So if it stretches it vertically, that also means it makes it narrower than the parent function. So that's why y equals 3x to the fourth is narrower than y equals x to the fourth. The vertical translation of minus 18 moves it down. It moves it down 18. So that's why y equals 3x to the fourth minus 18 is narrower, and the vertex, or the entire thing really, is shifted down 18. Let's look at the next example. All right, so parent function for this one would be y equals x cubed. All right, so in this case, you have a horizontal translation, which is the number that's adding or subtracting on the inside. In this case, it's minus 2. You have a vertical translation, which is the plus 4, so it'll be up 4. And then the 5 is going to be, it'll be stretching it the same way. So the horizontal translation we will look at first. Minus 2 on the inside means it moves it right 2. If it was plus 2, it moved it left 2. So y equals x minus 2 cubed is shifted to the right 2 from the original. The leading coefficient of 5 will stretch it by 5. So it'll make it narrower than the parent function. And then the vertical translation of plus 4 is going to shift everything up 4. So in the triad example here, it's not asking you to draw anything. It's just asking you to identify what are the things that are going to transform the graph. What is the parent function? First figure out what is the parent function, then figure out what the transformations are and how they would affect the graph. All right, I'm going to pause here, and then you come back and check if you have the same answer.